Christopher Nolan's Interstellar, it has to be one of the most visually stunning science fiction films ever made. I mean, from that shimmering wormhole all the way out by Saturn to the terrifying beauty of the black hole Gargantua, it's just an absolute spectacle. But what's really cool is that holding all that Hollywood magic together was a super strict set of scientific rules. And that's all thanks to its scientific advisor, the Nobel Prize-winning physicist Kip Thorne.
So that brings us to the big question, right? How much of what we saw up on screen is actual established fact, and how much of it is just a creative leap? Well, to figure that out, we're actually going to use Kip Thorne's own framework from his book, The Science of Interstellar. He breaks it all down into three simple categories: truth, educated guess, and speculation. All right, let's kick things off with truth. This is the stuff that's grounded in the solid, well-established laws of physics. Things we've actually tested and observed. And the most mind-blowing example in the entire movie comes straight from the ideas of Albert Einstein himself.
I think everyone remembers that incredibly tense visit to Miller's planet. The crew lands thinking they're just popping down for a quick look around, but for every single hour they spend on that giant water world, 7 years pass for their buddy Romilly, who's waiting for them up in orbit. It's an absolutely gut-wrenching part of the movie. And believe it or not, it's based on very, very real physics. This crazy time-bending effect is called gravitational time dilation, and it's one of the wildest predictions from Einstein's theory of general relativity. See, his theory says that massive objects don't just pull things with gravity. They literally bend and warp the fabric of space-time itself. The insane gravitational pull of a supermassive black hole like Gargantua warps space-time so much that time itself actually slows down for anything that gets close. This isn't science fiction, folks. This is a fundamental part of how our universe works. Okay, so let's move on to the next category, the educated guess. Now, these are ideas that totally fit within our known laws of physics. They're theoretically possible, but we've just never actually seen them in real life. And the film's main way of getting around the cosmos? Yeah, that's a perfect example. For decades, sci-fi has always shown us wormholes as these 2D tunnels or maybe a swirling vortex in space. But Interstellar gave us something totally different, a perfectly calm, shimmering sphere just hanging out in space. So why the change? Well, it's because Kip Thorne and the filmmakers wanted to show us what a real three-dimensional shortcut through space-time might actually look like. So the logic goes like this. Since a wormhole connects two different points in our 3D space, its entrance, its mouth, has to be a 3D object too, and that's a sphere. So as the Endurance gets closer, it can actually fly all the way around the sphere and see the galaxy on the other side, with all the light being beautifully bent and distorted by the wormhole's gravity. It's almost like looking into a giant cosmic crystal ball.
And that brings us to our last category, speculation. This is where the movie takes its biggest creative leaps. It takes inspiration from some really out there frontier ideas in physics and just runs with them to tell the story. And this is where we get to the movie's truly mind-bending climax.
So, after Cooper falls into the black hole Gargantua, he doesn't get crushed into nothing. Instead, he ends up inside the Tesseract, this bizarre, seemingly infinite library of his daughter's bedroom. It's probably the most abstract and confusing part of the whole movie. So, what in the world are we actually looking at here? Okay, so to wrap our three-dimensional brains around this, let's just build it up, one dimension at a time. A point becomes a line becomes a square becomes a cube. Well, if you could move that 3D cube through a fourth spatial dimension, you'd get a tesseract. What the movie does is visualize this tesseract as a place where time itself becomes a physical dimension, a place you can move through. It lets Cooper see every single moment in Murph's room all at once, laid out like a physical landscape.
Right, so why was the Tesseract even necessary? It all comes down to solving that gravity equation. This was humanity's last shot. The goal was to basically crack the theory of everything by connecting the physics of the really big stuff, like planets and galaxies, with the physics of the really tiny stuff, quantum mechanics. The movie speculates that the one missing piece of that puzzle, this quantum data, could only be found inside a black hole's singularity. So Cooper uses the Tesseract to send that data back to Murph, letting humanity finally master gravity and escape our dying Earth.
So, we've gone through the truths, the guesses, and the speculations. But you know what? The story doesn't end there. In what has to be one of the coolest twists ever, the process of making Interstellar didn't just borrow from science. It actually ended up contributing to it. For real. So, to create scientifically perfect images of Gargantua and that wormhole, the visual effects team, a company called Double Negative, couldn't just use their normal software. It wasn't powerful enough. They had to write a brand new rendering program from the ground up, based on pages and pages of Kip Thorne's actual general relativity equations. This let them simulate, for the first time ever, what light would really do as it gets bent around a spinning black hole. And the results were so groundbreaking, they completely stunned the filmmakers and the scientific community. The simulations weren't just gorgeous to look at, they were scientifically accurate predictions of reality. In fact, the Institute of Physics actually said the team turned science fiction into science fact. I mean, how cool is that? What started as an effort to make a movie ended up creating legitimate scientific insight. This wasn't just some Hollywood backpatting. This work produced some of the most advanced visualizations of gravitational lensing anyone had ever seen. It was so important that it led to the publication of 2 scientific research papers, co-authored by Kip Thorne and the visual effects team, in respected science journals. The code they wrote for the movie is now an actual tool that scientists and students use for real research. And that just leaves us with this really amazing thought. We expect big scientific breakthroughs to come from labs and universities, right? But Interstellar proves that they can also come from this incredible fusion of art and science. It shows that just trying to create something beautiful and compelling can push the boundaries of what we know. It really makes you wonder, if a Hollywood blockbuster can publish legit research papers, where's the next great scientific insight going to come from? Hey, if you had fun diving into this with us, please make sure to like and subscribe for more deep dives into the science behind the stuff you love. Thanks so much for watching.